Hello, I'm William Preblon, a student from the University of Florida, and I'm excited to present the paper Leveraging Syntactic Dependencies and Disambiguation, the Case of African American English for the 2024 Joint International Conference on Computational Linguistics, Language Resources, and Evaluation. So African American English is a language spoken primarily by African Americans. Although it shares some similarities with mainstream American English, the dominant variety of English spoken in the US, there are key features that separate the two languages, such as the habitual be, person-number disagreement, multiple negation, and no copula. Despite being spoken by a substantial portion of the population and appearing frequently online, NLP performance on AAE continues to suffer. AAE is considered a low-resource language, meaning it faces the challenge of insufficient data for training natural language processing models. Quality annotation by native speakers is a time-consuming and expensive process that is not always an option for all projects. At the same time, AAE has very limited language-specific NLP tools. Underrepresentation of AAE in NLP tools can lead to linguistic and racial bias that negatively affect the speakers and promote harmful understandings about the language. These issues lead us to our research question. How can we develop NLP systems capable of recognizing AAE features and automating the annotation process, reducing reliance on large amounts of training data? This presentation describes a syntactically informed classifier designed for the automatic detection and disambiguation of AAE's habitual be. Building on previous research that explored part-of-speech tagging as a disambiguation parameter, our study delves deeper into the complex syntactic patterns occurring with habitual and non-habitual usages of be. Using linguistic data from 2 oral history corpora of AAE speakers, we demonstrate that integrating dependency parsing enhances automatic detection compared to the baseline in previous POS-only approaches. The success of our approach highlights the importance of incorporating unique linguistic features of marginalized language varieties in NLP models. So, the habitual be is a well-documented linguistic phenomenon in AAE. It is described as an aspectual marker denoting a recurring or habitual action. In contrast to other instances of be, it is invariant, meaning its form never changes to agree with the subject. The habitual be is relatively rare. However, detecting unique aspects of AAE has been shown to mitigate bias within natural language processing systems. In recent years, there has been an explosion in NLP research for AAE. Studies have explored various aspects such as building dependency parsers for African American English tweets, POS taggers built on subtitles and lyrics, AAE features that trigger hate speech misclassification, and many more. Roller 2015 highlights the values in using oral histories as sources of linguistic data. Most NLP research conducted on AAE focuses on Twitter data due to the prevalence of the language online. However, using oral history exposes us to extensive amounts of organic and authentic utterances. Oral histories also serve as valuable resources for studying AAE in various contexts and examining variation on factors such as class or gender. Santiago et al. 2022 proposed a disambiguation method for the habitual be, relying on the part-of-speech tags of be and its surrounding words. This research serves as our primary basis as we extend their role-based POS method to include dependency parsing structures as a parameter for the disambiguation of the habitual be. Following the work of Roller 2015, the bulk of our linguistic data comes from 2 African American oral histories. The first is a corpus of regional African American language, or the Chorale, which was the first corpus of African American speech published in 2018. This corpus has over 220 sociolinguistic interviews from speakers born between 1888 and 2005. Our second corpus is the Joel Buchanan Archive of African American Oral History from the Samuel Proctor Oral History Program at the University of Florida. This contains over 700 oral history interviews with African Americans throughout the South and was the bulk of our initial linguistic analysis. To address the challenge of limited training data for AAE, we approach the language as a distinct linguistic system, leveraging both published linguistic literature and our own analysis of AAE speech data to uncover the unique morphosyntactic environments of the habitual and non-habitual be. Using spaCy, we parsed 250 sentences from the Joel Buchanan archive and discovered 4 syntactic environments correlating to the habitual or non-habitual be. SynPar1 and SynPar2 correlate to the non-habitual be. We found that when B is tagged as an auxiliary and it has a child or sibling that is also tagged as auxiliary, it is most likely a non-habitual usage of the word. Further analysis found these sibling-child auxiliaries to be modals, suggesting that modals are unlikely to appear with the habitual B. The two remaining rules, SynPart 3 and SynPart 4, correlate to the habitual B. For SynPart 3, we found that a B is likely to be habitual if it is tagged as an auxiliary and has a head that is a verb, as shown in the first image. SynPart 4 diverges from the typical understandings of B as an auxiliary, instead finding instances where B is labeled as a verb. These patterns not only confirm what is already published in linguistic literature, but also suggest new ways of understanding computational representation of African American English. The habitual B disambiguation task is treated as a text classification problem, where each sentence is treated as an individual data point. The dependency parsing rules in Santiago et al. 2022's POS rules are scripted into Boolean statements, with 1 indicating the linguistic pattern is present in the sentence and 0 indicating it's not. Each data point is then classified as either habitual or non-habitual. Several experiments were conducted to test the hypothesis that adding additional linguistic information improves classification rates. We first began with the baseline of bigrams and unigrams surrounding B, testing the effectiveness of basic linguistic information. Part-of-speech, dependency patterns, and post hoc rules represents linguistic patterns informed by AAE from both published literature and our own analysis. Interactions of patterns explores how different linguistic contexts interact to indicate habituality. Finally, we looked at other types of data such as simple part-of-speech windows and data augmentation to see their effects on classification. Here are our results. Top to bottom demonstrates the inclusion of AAE-informed linguistic data, while left to right signifies the integration of uninformed information. Our results show that the simple baseline model is insufficient with limited natural data, achieving only a 0.29 F1 score. However, feeding just a simple representation of the POS data brings a large jump in performance, bringing the F1 score to 2.66. As we move into syntactically informed data, we see a gradual increase in the F1 score. Our best results without data augmentation comes from Model 5, which includes both simple and syntactically informed POS representations, as well as syntactic parsing and post hoc patterns, achieving a 0.83 F1 score. This is surprising, as we expected Model 6, which includes rule interactions, to perform the best. In conclusion, our study leverages the unique morphosyntactic features of African American English's habitual B to develop a classifier driven by linguistic insights rather than extensive amounts of data. Using a combination of POS tags and dependency relations, our habitual class achieves an F1 score of 0.83 without data augmentation, marking a significant improvement over Santiago et al. 2022, who attained an F1 score of 0.652 with such augmentation. From this, we conclude that models informed by AAE syntax outperform those that don't, as evidenced by the gradual addition of linguistic information. Our findings underscore the critical role of leveraging existing linguistic scholarship and expertise in crafting NLP systems for low-resource languages. This has broad implications across domains such as healthcare, education, and psychology, extending our research beyond African American English. And that concludes this presentation. I would like to thank my co-authors, Alice Rosette, Josna Goda, William Dyer, Kevin Tang, and Sarah Muller for their hard work and contributions. I'd also like to thank the University of Florida's Department of Linguistics and the Heinrich Heine University Dusseldorf Department of English Language and Linguistics. Thank you all for listening.